All right, welcome back. We're almost there. We only got a little bit longer. Today, what are we doing? We're continuing some work in 17.2 on some shapes. In particular, we've been working on parallelograms and triangles. Let's see, and trapezoids. I guess that's not quite parallelogram.
Now I'm curious, what are they doing this now?
What?
Your neighbors.
I have no idea what they're bumping, but it's fucking annoying as fuck. All right, and in this section, we looked at perimeter and area for each of these things. And so as a problem comes up, since I know many of you weren't here and or don't remember, I will relist the equations that go with them. So for start off, gables, triangular gables appear in construction. And generally the roof, these are like the roof kind of thing. And the roof part all has same on each side. They try to make it look like uniform. And then the base might be different. So in this case, we'll have a base of 32 feet. And we need to know like how much wood is needed to build this. So what we're really asking for here is the perimeter. The perimeter is the distance around, as a reminder. And you really don't need a formula if you've got a picture, just add up the sides. So the perimeter of a triangle is you add up A, B, and C, the three sides, 18 plus 32 plus 18. And let's see, 32 and 18 is 50, plus another 18 is 68 feet. So we need 68 feet of wood to make that triangular gable. We've only been fucking going like a third of a page. You already trying to disrupt my shit?
It's just a question.
But you clearly know I don't have fucking start, but you want to know if I'm fucking drinking fucking horse semen again, is what this is. You got that shit in your head. I know it is. You a fucking filthy minded person. That's coming from something from when I'm saying it. I know it's filthy because I'm over here encouraging a student that is transferring soon. He's giving a pick of places like here, somewhere, or San Diego. I'm like San Diego. It's fucking like basically spring year round. All the honeys are wearing short shorts all fucking year.
You're not wrong.
I ain't wrong. I ain't lying. It's fucking real. I went to grad school in Santa Cruz. I'll tell you that shit wasn't easy as a married man. It's just everywhere, year round. You just look, yeah, how you not look?
It's called the hot girl summer.
perpetual though. This coast never gets cold, never gets hot.
No, Cindy was really.
Even though we don't really need area for gables. We're gonna talk about what the area of the triangle is. So area of a triangle is 1/2 base times height is one of the options. Where B is the bottom. H is this distance right here. In this case, we don't have that right now. We don't have H. So we have to use a backup. There is another formula for area for a triangle. And it's a little more complicated. It is S times S minus A times S minus B times S minus C, and then you take the square root. And S equals 1/2 of A plus B plus C, which is 1/2 the perimeter. This is called Heron's formula. Well, we already found P for this triangle. P for this triangle was 68, so S is going to be 1/2 times 68, which is 34 feet. Which means we can calculate A. This is why we did all that square root shit. We needed triangles a lot. S was 34. And then if I just call this A, B, and C like this, I got S is 34 minus A is 18. S is 34 minus B, which is 32. And then S minus C is 34 minus 18. So what is this? I've got square root of 34 times 34 minus 18 is 16. Times 34 minus 32 is 2. And 34 minus 18 is 16 again. I guess I don't need all that extra. I know since we did this in the last chapter, when we got 2 of them, this is 16 squared. And we have the square root of it, that's just going to come out as 16. And then I have 34 times 2 left. It's 68 on the inside. I don't know what that is though, so I'm going to pull out my trusty phone. Left my phone in my pocket. No, there it is. Start wearing my fucking phone around my neck. Square root of 68 is approximately, that's 8.246 to 3 decimal places. I'll give it 4 decimal places. Now we need to multiply it by the 16. So the area ends up being for this triangle. $131.9, we'll say 94. And since the units were in feet, this has got to be square feet because area doesn't have a single dimension. Later on, we'll figure out a way to get H. Well, I don't know if we will for this class. In some cases, we'll have a way to get H. But this formula is pretty straightforward. It's just plugging things in, subtracting, and then taking the square root. It's all just calculator work as long as you remember the formula. Let's keep going. We could do a trapezoid. Let's say I got a trapezoid that looks like this. That's a trapezoid shape. Let's say that is 72 millimeters. This is 57.3 millimeters. This right here is 60 millimeters. And this right there is 120 millimeters. And the vertical height is 57 millimeters. So some things we're gonna find the perimeter in the area. The perimeter is again really easy, just add it up. Add up the sides. The area for a trapezoid is 1/2 B1 plus B2 times H. Where like this is B2 and this is B1. The two flat surfaces that are parallel. That right there is H. So if we do the perimeter and we add it up, I've got 72 plus 57.3 plus 60 plus 120. And these are all millimeters. Let's see, what do I get? 60 and 120 is 180, plus 72 is 252. Plus 57.3 is 309.3 millimeters, I believe. You got a calculator, double check that. I'm doing that in my head. Is right? And if we want to find the area, we got to do 1/2. The two bases, 57.3 plus 57. And then, nope, plus 120. Bottom base is 120. And then I got to multiply it by the height, which is 57. There we go. And I ain't doing that shit in my head. Fuck all that. 177.3 times 57 divided by 2. I am getting 5,053.05. And I guess we're going with square millimeters. All right, you ready for some more fun? I think you are. You have that look on your face that says, yes, let's do it. What? Good stuff. Let's do a fucked up triangle. Triangle that looks kind of like that. And we will call this 15 centimeters. And we don't know what the other two sides are, but we know that this is 21 centimeters from the apex. That's called the apex, it's the top.
Is this part of the trapezoid?
This is triangles.
Yeah.
So this falls under triangles. Triangles, the area is 1/2 base times height. And even though the height of this triangle is not going through the center of the triangle, 21 is the height. And the base is 15. So the area of this triangle is going to be 1/2, 15 centimeters times 21 centimeters. And we're going to end up with some squared centimeters on there. (157.5 centimeters squared). And since we don't have the sides, the other side of the triangle, we can't really find the perimeter on this one. Give you a fucked up one now. Now let's start looking at composite shapes. So the first one we're going to do looks like this. That makes a right angle, and I didn't draw this to scale very well because I'm going to say this is 10 inches, this is 12 inches, this is 17 inches, and that's 13.4 inches. And we're going to find the perimeter and the area. We're going to do the area 2 different ways. We'll see if we get the same thing. Okay, so perimeter should be easy. Perimeter is just, again, add up the sides. I've got 10 inches plus 13.4 inches plus 17 inches plus 12 inches. If you notice when I do it, I just go around in a circle. That way I make sure I don't skip any sides. And I think that's 52.4 inches. Right? Okay. Now, in terms of finding the area, we got a couple options. We could rotate this on this side. Now let's list them. Area option 1. Rotate it on its side and use trapezoid. That will work here fairly well. So I'm going to redraw the image. And I can see that my 2 parallel ones are the 10 and the 17. So I call this one B1 and this B2. Recall this is 1/2 B1 plus B2 times H. And since this makes a right angle, This is actually H. So I have 1/2 times 10 plus 17 times 12. And these are in inches and those are in inches. This is 6 times 27, which is 120, and 42 is 162 square inches. I think that's right. We should get that going the other way. The other option is treat this as a rectangle and a triangle. So I'm going to resketch it. If I make this into a rectangle or a triangle, what I can do is just like draw a line this over like this and make these like right angles. Now I have two shapes. I have a rectangle here. And I have a triangle right here. The area for a rectangle is length times width. It doesn't matter what I call each one of these here. I could call the 12 the L and the W the 10, or I could call it the other way around. But that, the way I did it, is 12 times 10 is 120 square inches. And that covers the rectangle. Now, what about the triangle? The area of a triangle is 1/2 base times height. If I call this the base, I see that's the same thing here, that's base. What's my height?
17,
No,
10.
no. You guys are barking up the right tree. 17 is the full length of this line right here. 10 is the length right here, but that matches up with this right here. This part's 10 as well. So what does that mean? This has got to be why?
It's 7.
Yeah, it's 7. The reason why is these two parts have to add up to the 17. So if I don't know what that is, I could say that's X. X plus 10 has to equal my 17. So we subtract the 10 and we get X equals 7. So we'll put that in here. I've got 1/2 the base is 12 times 7, which is my height. It should give me 42 square inches. And now if I add together my two areas, the area of the rectangle plus the area of the triangle. 120 plus 42 inches squared gives me the 162 square inches that I had up above. Now, the second way took more work, but sometimes it's the only option you have. We got lucky that this last one shifted into a trapezoid. We had something for it, but the next shape, we're not gonna have that option for it. So I wanted to start getting you, having you thinking about different shit. You guys ready for some more? All right. Let's do it. Our next shape is like this. So this side over here is 8 feet 6 inches. This is 5 foot 6 inches. This is 12 foot 6 inches. This is 3 feet. And that's all we know. The other thing we do know is these all make right angles here. Despite my shitty design, this line on the bottom is supposed to be straight. That line, straight line, is brought to you by, what else is in Mr. Jones's Dr. Pepper up here? Just Dr. Pepper. There's a lot of ways we can do this. I want to talk about them all, just, and then I'm going to pick one. Because I want you to be able to think about shit like this in the future. We could make one big rectangle. Option A. Make a big rectangle. And subtract the little rectangle. So the big one's the whole picture. I'm going to call that right there a little rectangle. Option B. I could redraw this thing. I'm not going to put the numbers on it, but I'm going to just sketch it. And I can treat it as two shapes put together like that. And option C, similar idea, but doing the two shapes like that. I'm going to do option C. Which means I need some other stuff. And no matter what I did, I was going to need some other stuff. I don't know what this length is right here, and I don't know what that length is right there. But I need X to do the option C, and I needed Y to do option B, and I needed both to do option A. So how can I find X? You're assuming it's a cut in half. It's not. We do know this side over here is three though. So we're gonna do the similar idea of what we did last time. It does kind of look like it's in half, I agree. That's just my shitty sketching skills. My bad, that does totally look like it's in half. I know this whole thing, this x plus this 3. That would be 3 right there. The x plus the 3 has to equal the 8 inches or 8 feet 6 inches. And 6 inches, how much of that is that of a foot? In a decimal form. What? How much is 6 inches in a decimal form? If I wanted to convert it to feet. We got the 6 inches, there is 12 inches in 1 foot. So we have 6 over 12 is 1/2, which is 0.5. So this is like x plus 3 equals 8.5 feet. That was the idea right there, what I was going for. Because turning it into a decimal is going to make it a lot easier to find the area. Maybe not the perimeter we could still add fairly easy, but the area is going to help. So here we subtract the 3. And I get x equals 5.5 inches. Or 5.5 feet. Which is the same value as that. That's 5.5. We already said the 6 inches was a 1/2 foot. So I'm going to rewrite down what all these are in feet. They all had 6 inches, so I'm just going to write them as 12.5. So now I have a box on the top and a box on the bottom. And this is 5.5 times 5.5. And this is 3 feet by 12.5. By the same thing we did right here to find x, we could find y. We could say y plus the 5.5 we have on top has to equal the 12.5 on bottom. So y has got to be 7 feet. Put that right there. That part's 7. And we have the whole thing over here is 8.5 for the whole distance. So we want to find the area. We can do the area thing on the top. The top thing is a square, which is technically a rectangle, but the area of a square is just s times s, or s squared. I like it better as s times s because it looks like ass. That's easy to remember. And these are my s's. So the area of the square is 5.5 squared, which is clear. $30.25 square feet. The one on my bottom is my rectangle. And that's just length times width. The length is 12.5. The width is 3. So the area of the rectangle is 37.5 square feet. So the whole area of the whole shape is adding them together. The area of the square plus the area of the rectangle. 30.25 plus 37.5 is 67.75 square feet. Oh, there's Bertha.
Hello.
Hey. You guys ready for some more? Oh, perimeter. We found all the sides. Perimeter is the 8.5 on the left, plus the 5.5 on top, plus the 5.5 here, plus the 7 there, plus the 3 there, plus the 12.5 here. And these are all in feet. So let's see, I got 10, 21, 32. I think that's 32. Yeah, it is. What? 42. 42? 42. Thank you. Which, interestingly enough, is the same perimeter as if we had done the big rectangle. 8.5 here and 12.5 here. Same perimeter. If you have a rectangle and you cut another rectangle out of the side, the perimeter still stays the same. That's kind of fucking neat. It has to be rectangle cut out of a rectangle, but. Or, you know, square out of a rectangle, shit like that. As soon as you start making like triangle divots and shit like that, it doesn't work. All right, let's take a look at another fucked up one. You all have seen barns. Good barn. Those are doors. This is called a gambrel roof. This shape. The shape of this roof is called a gambrel roof. And the end of it has the shape that looks like this. Which is basically looks like a triangle on a trapezoid. trapezoid. So if you wanted to find out how much wood you would need to cover the end of something like do this area. Find the area of this part right here. If we have the following dimensions. Let me draw a bigger gambrel roof. This is going to be 5 foot 4 inches. This right here will be 8 feet. If you wanted, we can break it up to where it looks like this. This distance right here is 23 feet. And each of these side distances over here is 10 feet. Now, we do have the option of doing this as a big triangle, 2 little triangles, and a rectangle. But we have a formula for trapezoid, and I think that will speed it up. So recall the area of a triangle is 1/2 base times height. And the area of a trapezoid is 1/2 B1 plus B2 times height. So how can I find what I need from the picture that we have? I'm going to redraw the triangle and the trapezoid so that we can try to label them. The triangle is showing that this is 5 foot 4 inches. 4 inches in terms of feet. I put 12 inches on bottom, 1 foot on top. This is 1/3 of a foot, which is 0.33. So I could say that height is 5.33 feet. What's my base here? What? Not quite, close. 23. This line right here is the same thing as that line right there, which is my base, 23 feet. Which is actually the top of my trapezoid, so I'll put that in over there. The height of my trapezoid is listed as 8 feet. What's the bottom of my trapezoid?
Um,
29.
It's 29. We have the 3 and the 23 and the 3. Sneaky, huh? All right, so let's start figuring out what these are. Area of the triangle is 1/2 times the base, which is 23, times the height, which is 5.33. And the area of the trapezoid is 1/2. 23 plus 29 times 8. Let's see, this is 52 times 4 is 208 for that one. Let's see about the other one. Oh, yeah, hi birthday, you messaged me. Did see it. 23 times
Yeah,
5 by 2. This one, I'm getting 61.295 on top. So maybe if we round it, we could round it to like 61.3. I probably wouldn't, I'm rounding here because the 5.33 was rounded. This keeps going. It is really 333333333. It just keeps going. So I might as well just, if I'm rounding, round to 1 decimal place, let's do 61.3. I add these up. The area of the gambrel end is 269.3 square feet. Approximately. There was some rounding there, but we'll call it approximate. All right, you guys ready for another shape? Fucking the Mecca big boy. And we just want the area. We don't want the perimeter because I don't know the diagonal lines. Just find the area. Which is this region inside here. Maybe I'll put that 6 feet on the outside. Okay, I have some options. I could try to break these up into this is a triangle right here. And this is a triangle right here. And then I got a big rectangle and a little rectangle right here. But I don't know how tall this is. And even though it looks like it's exactly half on top and half on bottom, I don't know that it is. So I don't want to assume that it is. So I don't know if I can find the vertical heights of these small triangles right here. So I don't know that that's going to work. The other option I have is I can make a big rectangle And do big rectangle. And then I can cut out the shit I don't need. I can cut out the triangle. Subtract the triangle. And I can subtract the little rectangle. Which is this one, I'll call that one little rectangle. And I think I can do that. The only thing I'm missing is this side over here. Can I get that side? What is X? Bless you. Well, I know this portion right here is 12. And that portion is 4. So X should be 4 plus 12, which is 16 feet. So I have a big rectangle, which is 24 times 16. And I want to subtract a triangle that has a base of 16, that's this side over here, and a height of 8. And I want to subtract that rectangle right there, and that shows up as 6 foot by 12 foot. So the area of my big boy Roy, the area of my triangle, and the area of my vertical rectangle is, big one is 16 times 24. Let's see, 256 times 8. 16 and 4, 1932. Is that 1932? Doing this in my head. Nope, nowhere near 1932. That's once, yeah, fuck, fail. This is 384 square feet. Triangle is 1/2 base times height. 1/2 16 times 8 is 8 times 8, which is 64. And the area of the tall rectangle is 12 times 6, which is 72 square feet. So to find the area of the shape we're looking at, we need to do the area of the fucking crazy looking thing is the 384 minus the 64 minus the 72, which is 320 minus 72 is 248, I think. All right. Are you done with the crazy shapes? All right, let's go on to the only shape that has one side. What shape has only one side? Line. A two-dimensional shape. A circle. So we're talking about circles and we're going to talk about radians in this chapter. Because we've talked about degrees before and now we need to talk about radians. So let's just draw a big ass circle and start labeling some shit that we're going to need to know. God, I hope this turns into a circular shape. Meh, close enough. Fuck it. All right, obviously, we know the point in the center is called the center. The distance from the center to anywhere on the curve is called the radius. If it goes all the way through the center of the circle and hits the other side, the full length is called the diameter. The perimeter, for some reason, has been renamed for circles and circles only. It is called circumference. That's going all the way around. If you only go along a small part of it, if you only do like a portion of the circle, that portion is called an arc. If you have an arc, if you have the radius going off to two spots, this makes an angle we're going to usually call theta. The area, this is a sector. This region right here is called the sector of a circle. I'll kind of shade a little bit to say what I'm talking about. And there's a couple more crazy geometric things right here. We haven't done area yet. I mean, I haven't.
Is that? Or no,
Is what? What?
you know sector,
The sector is just like a slice of pie.
yeah, but in that corner,
That's the angle. And we tend to use, that's my angle. And it's pronounced theta. Theta. Or some pronounce it as theta. Theta. That's more Greekish, a Greek pronunciation. It is a Greek letter, so it's probably theta. But fuck it. I'm not Greek. We're calling it theta. That's a sector. Okay, so this is the radius, that side's a radius, the full thing is the diameter. This part right here is technically a radius too. So we can see that first thing we're gonna note is that the diameter equals the radius plus the radius. And we tend to call the diameter d. And we use r for radius, and radius plus radius is 2 radius. So d equals 2r. Some more stuff that we'll need at the end. If you've got two lines coming out from the center hitting the edges, and you connect these points right here, let's see if I can do this fucking very well. So I've connected where the radius hits the circle on two different sides. This thing right here is called a chord. That thing right there. And if you have a chord on a circle and you chop off like the extra part right here, this extra part right there is called a segment. That's all the vocabulary we're going to have here, other than pi. We got one more term. Now, fascinatingly enough, there is a relationship between the circumference of a circle, which we call c, the circumference, and the diameter of the circle. If you take the circumference and divide it by the diameter of any circle, you always get the same value. It's 3.14159. I had a few more decimal places written down. Oh, there. 3.14159, 2654. This keeps going. This number has the symbol that looks like that, and it's pi, but it's pronounced like pi. And sometimes they make it look all flat like that. I tend to not do that. I don't like the flat look. I like to give it a little bit of flair. This relationship is true for every single circle. It's just fucking incredible. And no matter how big the circle is, how small the circle is, you take the circumference and you divide by the diameter, you get this fucking number every fucking time. I don't know who came up with the shit, but it's fucking cool. Someone must have made it like a circle, like took a string and measured around it so they could measure the length, and then measured the radius, measured the diameter, and for some reason said, no, let's divide it. So yeah, I can rewrite this equation right here in terms of C. The circumference is pi times diameter. But I know D equals 2R. So I can rewrite this as pi times 2R. And we tend to write it with the 2 in front, 2 pi r. So depending on whether or not you have the radius or the diameter, there's two equations you can use to get the circumference, but it's a simple relationship between the two. We'll throw some more equations at you. Well, let's just add the area one right here. The area of the whole circle is pi r squared. Just the r squared, not the pi. So let's do a little bit, couple exercises, getting comfortable working with that. For all of these, let's find the circumference and area. Of, on A, we're gonna say a circle with a radius of 1.7 feet. So since we have the radius, I'm gonna use the circumference one that has 2 pi r. And I'll just do 3 decimal places from here on. 10.681, same units as the radius, feet. The area is pi times the radius squared, which is pi times 1.7 squared. All right, for number B, I say, because I know how numbers work. Number B, we're gonna have a diameter of 4.2 meters. So if I want to do the circumference here, I can either use 2 pi r or pi times d. And I already have d, so I'm going to just use that one for now. Pi times 4.2. And I'm getting 13.19 round up to 5 meters. And the area is pi r squared. I know d is 2 times r, which means r is really d over 2, or 1/2 d. So I can do that here. I can change pi into 1/2 d and then square it. So I want pi times 1/2 times 4.2. And then I'm going to square it. So that's pi times 2.1 squared. And for this, I'm getting 13.854. And this will be meters squared. Do one more. So 2 feet 3 inches. I want to do 2 pi r for circumference. I don't want to use 2 feet 3 inches though. All right, because the inch, I want them all to be the same units. So I've got 2 feet plus 3 inches, and I need to turn the 3 inches into feet. I can multiply by 12 inches over, or 1 foot over 12 inches. So it's 2 plus 3/4 or 3/12. Is 2 1/4, which is 2.25. Or 2 1/4. And so now if I want to find that value. I'm getting 14.137. And this was in feet. My area is pi r squared. And I hope you're doing these on your calculator to make sure you know how your calculator works well. You should get the same answers I am getting. Okay, we could do something a little different. Let's say I've got like a washer, but it's a really fucking big washer. Or a donut, basically. And we want to find the area if the outer radius is 9 inches and inner radius is 2 inches. Any ideas on how we can do that? Well. I can find the area of the big circle. But that's giving me the whole thing, right? I don't want the whole thing. What do I want to do? I want to what?
Maybe add both of them, and the two.
If I add both of them, it'll make a bigger circle. I don't want a bigger circle. So what this is saying is that's 9 inches. And that's 2 inches. If I did 11 inches, it'd be even bigger. If I do the area of the big circle, I'm getting the whole thing though, and I don't want the whole thing, do I? I want to take out, if I do the whole circle, I want to take out the little circle. Of the little one. Like if I cut it out. What does take out mean in math? Subtract. So I have the area of the big minus the area of the little. This is pi times 9 squared minus pi times 2 squared. And rather than shifting to decimals right away, I know this 9 squared is 81, so I have 81 pi minus 2 squared is 4 pi. So this is 77 pi. Then if I need a decimal, then convert it to a decimal. (241.903) square inches. All right. I'm not giving you any time to just fucking distract me, am I? Poor Ariana, she's just about to crumble over here. All right, let's talk about radians. So in the past, we said if we made a full circle, this was 360 degrees. This was on Wednesday of last week, if you weren't here. A full circle is 360 degrees. Radians is also a measure of angle. So degrees measure angle. So do radians. And if I do the same thing here, there are 2 pi radians. So 2 pi radians equals 360 degrees. And if I divide by 2, I see the relationship that we're going to use a lot. Pi equals 180 degrees. Pi radians equals 180 degrees. Radians, though, is just a number. No units on it. Whereas the degrees have units on it, they have degrees. So if we want to convert angles to or degrees to radians. There's two ways of writing this that make this pretty useful. I could write this as pi over 180 degrees. Or I could write this as 180 degrees over pi. They both equal 1. This is a unit conversion bridge, like we did feet to inches. I just did feet to inches a little while ago. We're going to do that same type of conversion right here. So with, maybe I should make some lines here. So that I didn't give myself a whole lot of space, did I? Do that. If I take the 20 degrees and I multiply by pi over 180 degrees. You'll see I get 20 pi over 180. And the degrees cancel out. I got a degree on top and a degree on bottom, and they cancel out. And this reduces. This is 20 over 180 times pi. And 180 is, I could do this as 2 times 10 over 18 times 10. And the 10s clearly cancel. And 2 over 18, 18 is actually 9 times 2, so I can cancel the 2's as well. And I get pi over 9, or 1/9 pi. And if you put that in a calculator, this is approximately 0.349 radians. If I do that with the 60 degrees, I get 60 over 180 times pi, which actually reduces to 1/3 pi, or pi over 3. This is approximately 1.047. This is actually has a lot of decimal places. If I were to keep writing everything that my calculator shows before rounding, it keeps fucking going. So, ideally, you leave it as pi in a fraction. And only switch to decimals when you need it, say for like area. Or circumference. Because if you have pi, you got a bunch of pies going all over the place, there's a bunch of these weird numbers with a whole bunch of decimals. You gotta write a whole bunch of decimals to maintain any form of accuracy. But if you just leave it as pi over 9 or pi over 3. It's 100% accurate as is, and then you convert it to a decimal when you need it. So why don't you guys try doing 175 degrees? Convert this. To radians. Try to do it as a fraction first. Then we'll go the other way, we'll do radians to degrees, and then we'll call it quits for the day. There's more stuff to do in this chapter, but we're running out of daylight. Not the easiest one, I should have done this, I should have given you like the 60. 175 isn't that easy. 175, they're both divisible by 5. Is 35 over 36. Pi. You divide 5 out of each, the top and the bottom, that's what you get. I have no idea what that decimal is. But we'll find out. Approximately 3.054. And now if we want to go the other way, if we want to do radians to degrees. Why don't you try pi over 6? We'll do them, we'll do them together. Pi over 4, pi over 2. So if you have this relationship up here memorized and how it lines up with that, whatever you have, you just try to put it on, multiply it by, so you get rid of it. If I have pi, I want to multiply by the version that has pi on the bottom. So I'm going to multiply each of these by 180 over pi. In each case, the pi's cancel out, and I do not need a calculator for what comes next. This is 180 divided by 6. which is 30. This is 180 divided by 4, which isn't as easy for people to do, but you could divide each one by 2 fairly easy and get 90 over 2. 90 over 2 is 45, and these are in degrees. If I have 180 degrees over 2, I have 90 degrees. I'm going to give you the formulas. We're not going to use them until next week, but I want you to practice doing these radiance things for Wednesday, not next week, Wednesday. The reason why what we're doing on Wednesday is why the fuck do we need a radiance? Well, it turns out we showed the picture of the arc, the length of the arc, length of an arc, usually called arc length, goes by the letter S. And S equals R theta. Radius times the angle in radians. If you have it in degrees, it doesn't work. It doesn't give you the right value in degrees. The area of a sector like the little pi wedge, it is 1/2 r squared theta, where theta again is angle in radians. So I'd like to use the angles to find out things like the length of part of the circle or part of the area, the entire circle. We need it as radians, not degrees. There's a lot more uses for radians and other things. But you guys are not going towards engineering, so it won't be as useful to you. A lot of the formulas in calculus are based on radians and not degrees. They get really ugly in degrees, but in radians, they're really easy. And that's it for today. We'll call that a wrap. We'll do some sample problems on this. We're doing arc length, we'll do area of a sector. We'll actually also look at area of a segment, where we chop off the part of it with the cord. Do that on Wednesday. And you are all free to get the fuck out.
Thank you. Bye.
Yeah, that didn't sound as good the way I said it today.